let's take a closer look at the frac data on one of these wells. So you're just looking at different stages for that well which is stimulated from the toe to the heel. What I'm going to do here is the direction or the azimuth of those frac data goes along the minimum stress, the frac direction, the natural frac that exists in the system. I'm going to take the orientation of my well in relation to those frac direction and also the average frac length I have for these stages, and I'll incorporate that in my field planning process. Now let's take a closer look and see how we can incorporate that. So we already went through the challenges we have from the surface point of view for a pad placement. Let's take a closer look at our subsurface and see what we are getting into. Now in blue, what you're looking at is the historical well logs that we have in this particular area. So we got all those wells and logs that are tied with it. And right there you're looking at a couple of surfaces, the top and base of our lower Eagle Ford. That's the area of interest for us. Now, how did I get to this point? This is a unified system. It's an integrated part of geology, geophysics, earth modeling, reservoir and production. So geologists went into those historical wells that we have in this particular area. They inserted the tops of the top peaks for my well that designates the top of my reservoir, and the bottom peak, the base peak, where it actually hard kicks into limestone. They correlated those peaks for all those wells and gridded them up. So right now what we have is the two surfaces, the top of our lower Eagle Ford and the base of our lower Eagle Ford. Now the next thing what we did is we created a framework, if you would, for this particular zone to understand the total size of our reservoir. And then all we did is we incorporated the facies that you're seeing on those logs and also the properties of the rock in relation to the porosity and permeability in order to come up with an earth model. So the earth model is going to dictate what are the zones of high total organic content. Okay? And that's where we need to go closely into the earth model, understand the TOC, understand the mechanical stresses that exist within the rock, and accordingly align our lateral so that it can effectively be drilled within this area and efficiently drain from the reservoir. So now for this particular well planning exercise, I will actually use the top and base surfaces for my field.